discuss the power flow diagram in three-phase induction motor. As we all know, three-phase induction motor, there are two parts, stator and rotor. We are giving the three-phase power supply to the stator. So here we start from stator three-phase input power. When we give the power to stator, then stator core loss will occur. It will occur due to the iron part. In stator core loss, there are two parts, hysteresis loss and eddy current loss. Your hysteresis loss will directly proportional to frequency and eddy current loss is directly proportional to frequency square. After the stator core loss, then another loss will occur, that is stator copper loss, which is directly proportional to I square, also known as I square R loss. After the stator copper loss, two losses occur in stator, then we get the air gap power PG, which is short form is PG, also known as rotor input. Rotor input, which is the stator output, which is the rotor input. Then after the rotor input, their rotor copper loss will occur, which is known as I square R loss in rotor. Then after the rotor copper loss, core loss in rotor core loss will occur, but that is ignored. That is very small, because your core loss is directly proportional to frequency and frequency square, as the rotor frequency is very small, as rotor frequency is S into F, as S is very small in running condition. So your rotor core loss is also ignored. Your rotor core losses are ignored. So everywhere your rotor core losses are ignored, this loss will not present anywhere. It is ignored. Then after the rotor copper loss and core loss we already ignored, then we get the mechanical power, which is also known as mechanical gross power, PM, denoted by PM. Another name is developed power, which is known as P developed. Developed power, as we know, developed power is the power which changes from one form to another. As electric power is getting changed to mechanical power, this is known as developed power or mechanical gross power. After the mechanical power or developed power, there is one loss will occur, friction and windage loss. Friction loss and windage loss, these two losses are separated. Here I add these four losses to one loss, friction and windage loss. Friction, this is occurred due to the friction in bearings, and windage loss, this loss will occur due to the wind drag. Also this loss, friction and windage loss, also known as mechanical losses. Sometimes it is also known as rotational losses. After this loss, we get the shaft power. Which is the output power. Here we are, input is the stator input, three-phase input, but your output is the shaft power, which we get at the rotor output. So if we define the efficiency of the motor in percentage efficiency, then it is output divided by input. Your output power is the shaft power divided by your input is the stator input. Your input is the stator input, that three-phase input which we giving to the stator. So your input is the stator input, this input, three-phase power input. So your input is the stator input. So PSS divided by P input stator into 100. This will get the percentage efficiency. So some formulas here also is important. From the equivalent model, we also known as the air gap power PG is equals to 3 into I2 dash square into R2 dash divided by S. Your copper loss PCU, these formulas we are deriving in three-phase quantities. These are copper loss in total three-phase equals to 3 into I2 dash square R2 dash. Your R2 dash, I2 dash means your rotor quantities are referred to the stator side. And mechanical power PM or developed power equals to 3 into I2 dash square into R2 dash into 1 by S minus 1. These three formulas are important. So from this formula, we can directly check that your copper loss is equals to S into air gap power or rotor input, and your mechanical power or developed power equals to 1 minus s into Pg, 1 minus s into air gap power or rotor input. So if we take the ratio between these three quantity, air gap power and rotor copper loss and PCU rotor, this is rotor copper loss, and mechanical power or developed power, your ratio will come, this is Pg, proposed ratio SPG is to 1 minus s into Pg. This ratio will come 1 is to s is to 1 minus s. This ratio is important as direct numerical will be framed from this formula. So we are all known as this ratio Pg is to PCU rotor is to PM equals to 1 is to S is to 1 minus S, 1 minus S. So another diagram we also refer to other diagram. If we directly look at the flow of the power, how the power will be flow from your starter input, P input starter. If we are subtracting the starter core loss, if we are subtracting the starter core loss and starter copper loss then we are getting the air gap power or rotor input from rotor input or air gap power, from rotor input or air gap power easy. If we are subtracting the rotor copper loss, then we are getting the mechanical gross power or mechanical power, otherwise known as developed power. From the developed power or mechanical power, if we are subtracting the friction plus windage losses, we are getting the shaft power, which is the output power, This flow is very, very important for the numerical solving in 3-phase induction motor. So we are concluding the power flow diagram in 3-phase induction motor.